So we have the Pythagorean theorem. Here's a little drawing. As you can see, this is a right triangle. In order to use the Pythagorean theorem, you have to make sure it's a right triangle. You can tell that it's a right triangle because it has a little box in the corner right there. Okay, so first things first, you need to identify that it's a right triangle. You've done that, perfect. Now you need to identify the two legs, leg A, leg B, and then across from the 90-degree angle, once again, that's right here, is the hypotenuse. So that's the hypotenuse. Leg A and B are adjacent, so they run right next to the 90-degree angle. Okay, we're getting there, almost there. So above we have the Pythagorean theorem, which is a squared plus b squared equals c squared. Now remember that each leg can be denoted with a variable. And on the last frame, we let one leg equal a, another leg be represented by the letter b. The hypotenuse traditionally is called c. And so with this picture here, we've called one leg a, and we'll let this one right here, this is a, and it's 3. Here's another leg, and it has a length of 4. Now we're looking to find c. So what we do here is we take these values and we plug them in to this equation. So in order to find c, we say 3, we have to square that, squared, plus we take the length of b here and square that, 4 squared, equals c squared. So this becomes 9 plus 16 equals c, and don't forget it's still squared there. And then this becomes, we simplify this further, these two integers can be simplified further, so that's 25 equals c squared. Now we take the square root, 25, and this equals c, which equals 5. And that is a solution. So now we've found the hypotenuse using Pythagorean theorem. Next we will find one of the legs using the Pythagorean theorem. All right, here we go. Okie dokie. Now we are going to solve for one of the legs instead of the hypotenuse. So let's begin by drawing our little triangle. Remember, it is a right triangle. That's how we know we can use Pythagorean theorem. Okay, so this time we're looking for A, and we've got one leg and the hypotenuse. The hypotenuse, C, let's say, is a length of 10, and the other leg, B, is a length of 8. Now the equation, the theorem, says that a squared plus b squared equals c squared. So we want to isolate this variable here, right? We're looking to solve for a. So let's subtract b squared from both sides to isolate that variable. So we've got a squared equals c squared minus b squared now. Okay, and we've got to just plug these values in. So first, let's put in that c, and we've got to square it, right? So we've got a squared equals 100 minus 8 times 8 is 64. So then we get a squared equals 36. Remember though, that's still the square. So we have to square root this and square root this. A equals 6. And we're done. So now you know how to use the Pythagorean theorem to solve both for the hypotenuse and for a leg of a right triangle. All right, good luck.